Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I want to give you the results of the test that I did. Now, this is just the operating system baseline. So what is it I'm trying to do here? I'm trying to compare FreeBSD 14.2. This will be ZFS 2.2.6. And I'm going to compare it against Ubuntu 24.10, also 2.2.6. And in both cases, the default file system for the operating system is ZFS using a single drive. And that single drive in both cases, this is both on the same machine, and it is using a Western Digital SN850X. I'll put the drive specs together in this video so you can see what the manufacturer says the hardware device specs will do. But as you will soon see, that won't mean anything because ZFS wants to do everything in memory. What are the differences between the settings? Well, there's only one that I had to change. So A time is defaulted to off on FreeBSD. It's defaulted to on for Linux. So I turned them both. I didn't do anything to FreeBSD. I turned them both off. The other comparison that we have to talk about, and this is the elephant in the room, I wanted to test the I/O engines to be more or less the same, right? So I wanted to do an apples to apples comparison as much as I could. So the default for FreeBSD, at least in the way that they set up the operating system version of ZFS, is to use psync. That is a synchronous I/O engine, meaning that every write gets eventually flushed to disk. Now, the way that ZFS does things like this is it doesn't force a write every time there's a block that's going out, because that's stupid. There's some really good reasons why ZFS does that. So the second thing is that before we go any further with the explanation, let me tell you what Linux is defaulting to. Linux has been using, they started experimenting with IOU ring, I think back in 2018, on any major distro of any note. Yeah, so you may find some older ones that are out there that haven't updated in years that are still running, some other I/O engine, but IOU ring is asynchronous. It is heavily optimized for performance. Now, here's a couple of things that I remember from my days working in Unix. I was around in the days so Unix originally was always synchronous. So we started experimenting with it, and I remember that if you, as the joke went, we started initially with AIO, and then they started working on POSIX AIO while I was there. And one of the jokes was, if you want the integrity was at risk. If you put AIO or POSIX AIO as your default engine, oh yeah, your integrity. The joke was, if you wanted to clean a disk the most efficient way, just put AIO out for your IO engine, because it would eventually self-destruct the drive. So yeah, it was like watching a Mission Impossible episode where the tape drive goes up in smoke.
As always, should you or any of your IM force be caught or killed, the Secretary will disavow any knowledge of your actions. This tape will self-destruct in 5 seconds.
SD has in the past used AIO. It's still around, but if you go out to the forums, you'll see people going, "Oh my God, don't use it! Don't use it! There's integrity problems. It'll blow up the world. Don't do it." That's why it defaults to psync and not AIO. However, FreeBSD is starting to look at IOU ring, which will be interesting to see how that transposes. It's not ready. At least I couldn't see anywhere where it was actually ready yet for deployment. Now, my tests today are not production ready. You would not typically configure ZFS the way I have it set up in a production environment. If in production, you would have an slog defined going to drives, and you probably would have you would have some other failover capability for your data. So I have FreeBSD 14.2. Now this pool I did set up to do an initial run. Today, though, I did set up my own pools. I did set it up in a mirror, And I did the same thing with Ubuntu, and I tested these under Proxmox virtual machines. So, but that's not the results we're going to look at today. That's my final test, not the test for today. Today is the baseline test. So, yeah, I need to retest both VMs under bhyve. Also, I need to retest them under Proxmox. So, all right, now I'm using IO Zone 3, so it's the latest one that's out there. I'm doing a benchmark test that's built into IO Zone, and it will measure about 14 different things that it'll look at. So the first things we're going to look at today is a sequential write, a sequential read, and then we're going to try our reread, which measures the performance of read the file, then reread it and reread it and read it. And then what this is looking for is how well or how much does cache play into read operations. And you'll see with ZFS quite a bit. All right, so speaking of that, let's take a look at the benchmarks. What do we get? So the initial writes for FreeBSD, there are 5 entries here. This is the top one, 7,153. That's with one simultaneous worker. The second one is with 2 simultaneous workers. And the 16,000 is with 3, and so forth until we get all the way down to 13,000. That's with 5. So you'll notice here just a general comment on the initial write. That's a sequential write to build the file that it's going to test with going forward. So you'll notice that it scales up pretty well up till about 4, and then it dies. It drops off really sharply at the 5th. Now, the initial write for Linux starts out pretty slow at 5,000, and it caps out at 11. You'll see a little bit of variance in there. I've always have seen this with Linux on these tests, and obviously for writing, FreeBSD is faster. Almost 2,000 megabytes per second faster. So what about the reread? The reread starts out at about 600, and it goes up to 28,000 for FreeBSD. But this is where Linux starts to take over, because Linux starts out at around 9,000 megabytes per second, and it caps out at 36,000. Now, clearly, this is well above the performance spec for the drive. So we know there is caching going on here, and we know memory is the culprit. The sequential reads, same thing. FreeBSD starts at around 8,900 megabytes per second and goes all the way up to 27,000. Linux clobbers it, starts out at 11,000 and goes up to 31,500 again. So the next thing we want to look at is stream reads. Now this uses buffers, and it is memory based anyway. So yeah, this is blocked. So it's going to try to use as much memory as it can in order to do reads. And then the writes, same thing. It's blocked, and it's also going to try to use it's stream writes. So what do we see here? So in this case, the reads are far superior on Linux than they are on FreeBSD. So we definitely have seen that before. And for some reason, the writes on FreeBSD just blow up. It's like it does not like freads at all. Now, that could be a bug. Yeah, I mean, that seems way off from what it should be. So there's something going on there it could be syncs that are doing it. Because these are block writes, that it might be going, oh, well, we need to write every block out to disk, which that's kind of what that looks like to me. It looks like it's doing a force write to a sync to disk every time it's doing a write. So, yeah, that would definitely affect performance. But, yeah, clearly it fell off the tree. So, yeah, it didn't do too well there. Next, we have mixed workloads, which are read and writes. Those, you might see these every once in a while in applications that have to keep going back and reading pieces out of the metadata. So you'll see they'll back up, they'll read some stuff, and then P reads are C. Those are buffer. Those are typically what the type of read that you do in a C program. So these are quite common. They're sprinkled all over the place in Linux and also FreeBSD. But they read a file without a file pointer change. That is, it will skip into the file by a particular record count. So you can advance where you want the read to start within the file. P-write, same thing. You can skip into the file a specified number of blocks and start writing. Yeah. So these get used a lot. So how well did these two systems perform? Well, we're seeing the same thing. Again, the mixed workload is about 50-50. It's 50 read, 50 write, 50% read, 50% write. So, yeah, you would kind of think that FreeBSD might have an advantage here, and it does. So it starts out where Linux is fast on the first, but Linux doesn't keep the scale. It drops back at the second concurrent user. This is why I always use concurrent users to see how well workloads scale, especially in a server environment where you could have an influx at the high traffic loads of the day. For example, people are logging in and getting email at 8 a.m. in the morning, and you're following the sun on corporations that are global. So you'll notice that as the sun rises in New York City, you'll see boom all these requests coming into the system as people initially log on, and then it'll move to Chicago in the an hour later. And so yeah, Linux does not do well in mixed workloads. And FreeBSD beats it. P reads, again, I don't have any skin in the game. I don't care which one's faster. I'm just going to tell you what I saw, and this is what I saw. P reads, FreeBSD is slower than Linux all the way across the board. There are no exceptions on any of the scaling, except they get a little closer on the number 4. For some reason, Linux doesn't scale up. It dropped back a little. You see, from going from 3 to 4. On 3 concurrent users, it went from 23,166 to 21,260. So, and I have seen that kind of behavior before on Linux. P writes, FreeBSD again does very well here in comparison to Linux. It beats it. So I would almost say that in the writes, FreeBSD is definitely faster than Linux is. So, all right, so now we have random reads, random writes. This is the big one. So these type of workloads are very heavily represented in databases, and they typically show up when you least expect. And as you can see in the random reads, Linux again does very well here. Now ZFS has this little game it plays with random I/O, because it wants to block a whole bunch of them up and then fire them all at once to the drive. So, and the same with the writes. It wants to kind of block them all up and fire them to the drive. On the writes, FreeBSD, I would say on the first concurrent user is faster than Linux. The second one, Linux picks up and beats the FreeBSD a little bit. It's a little faster. Then on the third, FreeBSD drops back to 4942. And Linux scales a little bit it falls back a little bit too, 5810 instead of 5967. Then on the fourth, they look like they're drawn even. That looks even to me. And then on the fifth, FreeBSD gets past it. But it's not much. It's about 203 megabytes per second. It's not a lot. Could be in the noise. These could be exactly equal in this case. Rewrites. This test measures the performance of rewriting a file that already exists. And so it's basically rewriting over the metadata and stuff. So and then you have reverse read. Compilers do this. Nastran does it a lot. And so yeah, you'll see it's a way that they do parsing in order to be more efficient. Stride reads it's reading an offset, and then it's reading the file, and then it's hitting an offset to advance into the file. This would be things like imagery that has NetF imagery is very common that it does strided reads. The metadata is up at the front of the file, and then somewhere embedded in that metadata is the pointer of where the image begins. And so, yeah, strided reads are used for that. So reverse read, we start out with 7,500 megabytes a second for FreeBSD with a single user, and Linux is around 9650 for that same that same workload. And then at the end, Linux actually falls back a little bit, and they're getting a little closer together, although not too close, because that's still about 4,300 megabytes difference per second difference. So yeah, clearly Linux, I think, won that one. Rewrite speeds, I'd say FreeBSD won that one. It's quite a bit faster than Linux is. So you can see they're kind of trading blows back and forth here. So be careful if you do benchmark these two. There are strengths in FreeBSD and strengths in Linux. I don't think this is one of those cases where you can say, oh, well, Linux is faster or FreeBSD is faster. No, they're both doing good in particular workloads. Stride read, I would say, yeah, FreeBSD is not so hot here. So let's get to the bottom line. So if I do a geomean on all the tests, which one's winning? And I don't put any weights on it. I just say, okay, of the 14 tests, how did this look overall? All right, so there's what we got. So FreeBSD on single user, one worker, 5,300, well, 50, let's call it 5,400 megabytes per second. And then for Linux, we'll call it 8,400 megabytes per second. So clearly, yeah, Linux won that one. Linux wins the second, the third. The fourth is pretty close, although not really close. And and it's not too far apart on the fifth. So FreeBSD is not radically slower. And remember, it could be just differences in the way the two are managing the file, or it could be how it's managing memory. So I guess what I'd like to do is take a few minutes here at the end and kind of give you a recap on all of the tests and what my final conclusions are here. I think that if you look at the benchmarks, I think you'll quickly come to the same conclusion I did, that Linux is best for read-dominated workloads. So if your workload is heavy reads, and that's all you do occasional writes, maybe it's 80-20 or 75% of the time you're doing reads and 25% of the time you're doing writes. Those kind of workloads are going to work very well on Linux. So what kind of workloads would those typically be? So that would be something that would be like streaming using freads. It would be something like if you were doing data analysis, like you had all this data that's sitting out there and you needed to compile it together and then analyze it. If you had, just heavy read patterns like you would for imagery, for example, or heavy reads. They also could be really heavy writes too. On the other side of the coin, for writes, I think you're going to find from the benchmarks that FreeBSD is better at that. And it shines in sequential and random write performance. Now, I'm going to clarify that one thing I didn't tell you was that the block size we were using is the default. 128 kilobits is the block size. Now, typically when you're working with larger files, you want to move that up to a meg. And I haven't completed that benchmark yet, so I'll get back to you when I do. What's the use case for FreeBSD? Well, I think that's a good choice for databases and logging, and even VM storage might be a good choice, provided it's more write-heavy than it is read-heavy. In mixed workloads, when you have a mixture of reads and writes, who's better? I think, again, even in mixed workloads, FreeBSD is probably a better choice. It has a balanced performance in mixed workloads that suggests it's better equipped for environments for both read and write demands, because remember, it wasn't that far off until you got into F reads and F writes. If you're doing streaming reads and streaming writes, go Linux. But if you're using P reads and P writes, that's what we're talking about. So yeah, so those are typically going to be file servers like NAS servers. They're going to be application servers for Java or Python, whatever you might be using for your middle tier. Anyway, that's all I had for today. I'm going to hush up now and let you come to your own conclusions. I'm not done. I've got a couple more things I want to do, so I'll be back. But I told you I would give you a progress report. Ta-da, there's my progress report. Hope to see you again soon.